one landscape. For machines, this is how neural networks learn to create. Autoencoder, VE, GN, and diffusion. Start with the autoencoder, a copy machine with a cruel twist. The encoder must squeeze the whole picture through a tiny bottleneck, a code of just a few numbers. The decoder then rebuilds the image from that code alone. Training is simple. Make the copy match the original. To survive the squeeze, the network is forced to keep only the essence: edges, shapes, structure. That makes autoencoders perfect for compression, denoising, and anomaly detection. But they're not true creators. Between their codes, the space is full of holes. The variational autoencoder, VE, fills those holes. Instead of mapping an image to a single point, the encoder predicts a small cloud, a mean, and a variance. We sample a point from the cloud, then decode it. A second loss, the KL term, packs all the clouds into one smooth, organized space. Now the magic: pick any random point, decode it, and you get a brand new, plausible image. The VE is a true generative model, with one famous weakness: its dreams come out a little blurry. GNs sharpen those dreams with a duel. A generator, the forger, turns pure noise into fake images. A discriminator, the detective, sees real and fake and must tell them apart. Each round, the detective gets sharper, so the forger must get better. Round after round, the fakes improve until even the detective is fooled. The result: stunningly sharp images. The cost: a duel is unstable. GNs can oscillate or collapse into producing the same few safe images. Powerful, but temperamental. Diffusion models learn by destroying. Take the landscape and add a little noise, then a little more, step by step, until nothing remains but pure static. Now train a network on one humble task: undo a single step of that damage. To create, run it in reverse. Start from random static. Denoise, 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 and watch an image crystallize out of nothing. Training is stable. Quality is state-of-the-art. This is the engine inside modern image generators. Its only sin is speed, hundreds of steps, which researchers now shrink with distillation. Now, here is the secret underneath all of this. Every generative model answers one question: how do I travel from random noise to the island of real data? The VE draws a smooth map of the territory. The GN learns the way by being challenged at every step. Diffusion simply walks there, one small step at a time. Different vehicles, same journey. And here is the plot twist of the modern era. The rivals became co-workers. Inside today's image generators, a VE first compresses the picture into a small latent space. Diffusion then works its denoising magic there, where computation is cheap. Finally, the VE decodes the result back into pixels. This is latent diffusion. Meanwhile, GN-style adversarial losses survive as sharpening tools, and VQVS discrete codes became the image tokens inside multimodal language models. Nobody lost the war. They merged. And the story is still accelerating. Flow matching straightens diffusion's winding path. Consistency models learn to make the journey in a single leap. Distillation compresses 1,000 steps into 4. And the very same denoising idea now dreams in full motion video. For classic machines, one unfinished story. If you prefer mathematics, here is the deepest unification of all. Every true generative model is minimizing a distance between two distributions, the data's and its own. The VA maximizes a lower bound, the LBO. The GN plays a minimax game on a divergence. Diffusion learns the score, the gradient of the data distribution itself. 3 very different losses. One identical target. Make P model equal P data. But here's a question your textbook will not ask. All 4 machines chase realism. match the data. None of them is rewarded for being different. Quality diversity algorithms flip the objective. Instead of one perfect sample, build an archive of many, each excellent in its own way. Add a surprise signal, and the model is paid to explore what it has never seen before. Imitation is nearly solved. Exploration is the open frontier, and that is exactly where research begins. For machines, one story. The autoencoder learns the essence. The VE organizes it, so you can sample. The GAN sharpens creation through competition. And diffusion trades patience for the best quality of all. Learn these four, and the whole field of generative AI reads like a single, beautiful idea. Generative deep learning. One landscape for machines.